Hello, my dear students, and I want to briefly go over the expectations for the lab report for the naming of chemicals, the wet lab portion of our experiment. It's the same experiment, but I've broken it into two parts in two separate grades. So if you look at what we did in the experiment, we're going to do the same thing we've been doing, only this time you are the ones who made the actual chemicals in a laboratory environment. So when we look at what we did, we mixed different chemicals. For example, silver nitrate here with iron chloride in the top left, and we put silver nitrate, a drop of silver nitrate, all the way down the row, and then in the row next to it, going down, we added a drop of lead nitrate. And then in the third row, though there are fewer boxes, we added copper sulfate. You can see the light blue drops because copper ions have that characteristic blue color. Finally, magnesium sulfate followed by iron 3 chloride. The iron 3 chloride has a characteristic light brown color, and you can see we also added iron chloride going across. And from the top down going across, we added drops of iron chloride, potassium iodide, sodium hydroxide, sodium carbonate, and sodium phosphate. Now, that was the instructions. Place 1 drop of each solution in indicated spaces below. Stir by mixing with an unused clean toothpaste. And after mixing, we saw that a reaction occurred. Specifically, that precipitates were formed. Even in some of the ones that didn't look like they formed a precipitate, for example, the magnesium sulfate, there were very light precipitates. It's real obvious down here. On these other two, when the solutions dried, you could tell there was a precipitate. And what we're going to do is go through and describe the reactions. And I will give you the official designations. Some of them were described as tan. For example, this one here. I could see that. Brown. Depending on your source, this is described as yellow, or I've seen it more frequently described as canary yellow. So we're going to go through and fill in each box and answer our required data. And so here's what it says. Write the formula name and the name of each compound produced by the mixings. So I'm going to go through and name them and just quickly go through. So when I mix silver nitrate with iron chloride, I make silver chloride. And when we look at what that precipitate looked like, let me get it here. It was an off-white precipitate, and we made a compound, silver chloride, AgCl. I'm only going to say it from now on. And in this box, we would write silver chloride. But there's no room for me to do it with my pen. But there is room for you to do it, as I'll show you, when you type in your answers in your lab report, in the form that I provided you. So going top to bottom, we have an off-white precipitate in box number 1. We'll just number top to bottom. 1, 2, 3, 4, 5. And in the second one down, it's called a light yellow precipitate when we react silver nitrate with potassium iodide. And we make silver iodide, or AgI. We are making AgI. And that is called silver iodide. The next one down is a brown precipitate, and it is what? It is a brown precipitate, and it would be silver hydroxide, AgOH. And when you write precipitate, I'll do it on this next one with the sodium carbonate reacting with the silver nitrate. The product is going to be silver carbonate, and of course silver is always +1 and carbonate is always -2, so you need 2 silvers and 1 silver carbonate. And that would be its formula. Its name is silver carbonate, and this gives a tan precipitate, and we frequently abbreviate precipitate PPT because there's often not a lot of room. Down below would be silver phosphate, Ag3PO4, and it gives a white precipitate. And if you want to see, I will briefly open that back up because here are the results, where we had top to bottom in the silver nitrate row. If I can get that back up. Oops. Go back. Oop. It's not going to go the way I want it to. Let me get back to it. My photos, here it is. Top to bottom in this leftmost row, we had off-white, light yellow, I don't really see light yellow there, brown, definitely brown, tan, sort of tan, and the bottom one says white. Those almost look reversed, but those are the official colors in our precipitates for our products. So you can write what you see, or you can write the answer. So let me see if I can clear some of this out and get this all erased. There must be a faster way to erase with this pencil, but I will get it back so we can make some notes as we go along. So in the next row, starting at 1, 2, 3, 4, 5, box number 6, 7, 8, 9, 10, I have a white precipitate formed, and it would be PbCl2, which is lead 2 chloride. In number 7, I had a yellow precipitate, that brilliant canary yellow. Again, you see the brilliant pigments, the whitest whites and the brightest colors that lead pigments and lead salts give you. That's why lead was used in paints, but unfortunately it's toxic. So number 7 is a yellow precipitate, and it's PbI2, lead 2 iodide. The next one down is a white precipitate, and it is lead 2 hydroxide. So number 8 is lead 2 hydroxide with a white precipitate, and the formula is Pb, and then parenthetically, so it's Pb, I'm going to start over here because I have room, parenthetically OH2, because I need 2 of these hydroxide polyatomic anions. The next one down is lead 2 carbonate, PbCO3. We've made a new precipitate. We're going to talk about this reaction in a bit, these precipitation reactions, but we're starting early. It was a white precipitate. It is PbCO3, and it is lead 2 carbonate for number 9. In number 10, again, we have a white precipitate. You would write white precipitate. It takes too long to write out precipitate. And that is lead phosphate, which you would write Pb3 because it's +2, and phosphate PO4 is -3, so you would need 2 of those. That's that 3 and 2 for 6 common denominator sorts of problems. So lead phosphate, and this is called lead 2 phosphate officially, and its formula is Pb3 parenthetically PO4 times 2. So let's go on to our next ones and finish this up. So this is 11, 12, 13, 14, 15, 16, 17, 18, 19, with my toolbar in the way there. So number 11 is a light blue precipitate. It's calcium hydroxide. Again, this would be CuOH2, parenthetically 2, and it would be called copper 2 hydroxide. And the next one is a light blue precipitate. It's copper carbonate, copper 2 carbonate. It would simply be CuCO3. And the last one again is a light blue precipitate. All these copper salts are light blue, and it is very similar to the lead phosphate because, like the lead, it has a +2 charge, so it would be Cu3PO4 inside the parentheses times 2. Copper 2 phosphate is its name, gives a light blue precipitate. So going up to number 14, where we mix magnesium sulfate with sodium hydroxide, we're making magnesium hydroxide, MgOH2. You may know it by its common name of milk of magnesia. It's an aqueous solution of milk of magnesia, of magnesium hydroxide, when you buy it at Walmart, and it's an aqueous suspension, technically, because the magnesium hydroxide does not go into solution. It acts as a suspension and therefore looks milky because of the precipitate. This magnesium hydroxide does not need a Roman numeral because magnesium is always +2. It's a group 2 metal. Number 15 is a white precipitate. It's magnesium carbonate, and it would be MgCO3. And the last one is magnesium phosphate. Again, it would be Mg2, and then parenthetically PO4, just like the copper and the lead, because you have a +2 cation and a -3 polyatomic anion with the phosphate. So magnesium phosphate, you don't need the Roman numeral though, and it's Mg3PO4 parenthetically, or grouped together, 2. And finally, these last 3 precipitates, they were varying degrees of orange. When I look at the key and the standard description of them, that seems to be just plain orange, but I saw 3 different shades of orange. So 17 is an orange precipitate. It's iron 3 hydroxide, and you would write that FeOH3 because it is iron 3, Roman numeral 3, hydroxide. The next one, 2 more to go. The penultimate one is also an orange precipitate here with number 18. It is iron 3 carbonate, and it would be Fe2, and then parenthetically CO3, 3. It's another one of those 2 and 3 ones. So Fe2, CO3 in parentheses with a subscript 3. And finally, the last one is an orange precipitate. It's iron 3 phosphate, but the iron 3 is a +3 and the phosphate's a -4, so you don't need parentheses. It's just FePO4 for the iron 3 phosphate. When you are done, your form should look something like this. If I may pull it up and you type in your answers, you'll see something like this. When you do it, that is my version of it. I didn't mean to do my keyboard. There we go. But you should type in some answers that look something like this. When you hand in your lab report, there are no questions, so we've reviewed the data. Your lab results look like this, and I will close for now and leave it at that. Let me go up here and close, and everybody stay safe and take care until the next time.